We have all hit that point of friction. You sit down to draft an email or analyze a brief, and before you can even ask the AI to do the work, you spend 3 minutes pasting in the exact same background information, company tone, and formatting preferences you used yesterday. The widely accepted fix for this repetitive loop is to graduate to the advanced features. You upgrade your account, unlock custom GPTs or Claude projects, and prepare to hand off the heavy lifting for good. You commit to the process. You spend hours uploading brand guidelines, feeding it past successful project examples, and writing out highly specific instructions so it knows exactly what to do. Then you give it a prompt, and despite that massive upfront time investment, the AI still skips step 3 of your instructions, hallucinates a new formatting style, and drops a crucial piece of context. This flowchart traces that exact user journey. You start with writing a simple prompt, experience the frustration of amnesia, overcompensate by spending 5 hours uploading instructions, and the path ends abruptly right here, in a stark red box, a false expectation of control. The platform itself isn't broken. The issue is that we are expecting these tools to operate with strict execution control, and they are built to do something completely different. Every major AI developer right now is marketing their own proprietary version of persistent project files. They all have different branding and different interface designs. Underneath the slick marketing, these features run on the exact same architecture. They are simply memory and identity layers. They are not rigid, rule-based code execution environments. To actually make these tools work for you, we have to separate the concept of persistent context from reliability control. They are two entirely separate mechanisms. Recognizing that distinction is the only way you can stop wasting hours building massive, complex workspaces that are designed to fail from the start. Let's look at the heavyweights first, starting with Claude. Out of all the tools on the market, Claude operates closest to a traditional, explicit file-based system. This comparison matrix highlights how the major players handle setup. We map Claude and ChatGPT against explicit file structure and UI-driven control. Claude's project files use markdown documents like identity.md or memory.md to create a structured, persistent context you manage directly. The trade-off is that you have to manually curate and update those files yourself. And even with perfect documentation, Claude will still occasionally drift away from your instructions mid-task. It cannot force a rigid execution path. Now look at ChatGPT. Instead of a strict file system, it leans heavily on UI-driven background awareness using its memory feature and custom instructions. As you interact with ChatGPT over time, it automatically collects your preferences, conversational habits, and saved facts in the background without you having to code a specific document. The trade-off here is a loss of granular control. You cannot easily dictate exactly which of those saved facts ChatGPT decides to prioritize when you give it a complex, multi-layered request. Whether you are managing explicit markdown files in Claude or relying on implicit memory in ChatGPT, both systems successfully establish who the AI is supposed to be. Neither can guarantee how it perfectly processes your task. This reality holds true even when we look at the lightweight tier, like Gemini Gems and Perplexity Spaces. Gemini Gems operate as distinct custom assistants. You upload a few simple files for context, write a brief instruction, and let it run. Perplexity Collections take a similar approach. They prioritize broad contextual steering to help you organize ongoing research, rather than trying to build deep, intricate personalization. Because both of these tools are lightweight by design, they share a very clear trade-off. They give you excellent broad directional steering, but they completely sacrifice any attempt at strict, step-by-step execution control. From the most complex corporate workspace to the simplest custom assistant, the entire market suffers from the same limitation in output reliability. Because they all share this exact architecture, we can group all of these tools together under one unified term, the persistent context layer. To understand the value of your setup time, look at this scorecard. Define the persona and role? Yes. Retain reference documents and background? Yes. Apply general styling and formatting? Yes. Guarantee exact reasoning steps? No. Produce identical, repeatable formatting? No. You can write the most massive, detailed rulebook possible, but an identity system cannot unilaterally solve a reliability problem. Once you accept what is actually on that scorecard, you have to completely reevaluate where you are spending your setup time. Let's map this out on a quadrant chart. The vertical axis represents the value of your invested time. The horizontal axis represents your user goal, from defining identity on the left to forcing strict execution on the right. When you spend time loading your basic company background and core preferences into the tool, you are operating in this upper left quadrant. This yields massive immediate dividends. But when you spend hours trying to force the tool to perfectly execute a rigid 10-step process, you drop into this lower right quadrant. The return on your time is almost zero. The harder you try to force strict automation out of a simple workspace feature, the lower the actual value of your setup time becomes. If you are a casual user just looking to optimize your day, your playbook is simple. Set up your baseline preferences once, keep your instructions brief, and enjoy the convenience of not typing the same preamble every morning. If you are a power user trying to architect a flawless workflow, you need to stop trying to build unbreakable multi-step machines inside a simple prompt interface. It will break. Look at this interaction. The workflow architect makes a core mistake. They attempt to treat a fluid, language-based tool like a rigid engineering problem. If you jam a rigid metal gear into a flowing water wheel, it violently sparks, grinds, and shatters. The final rule of thumb is this: utilize your project files exclusively to define who the tool is and what it knows. You still have to actively guide how the tool thinks, step by step, during every single query you run. The workspace handles the background. You handle the driving. Letting go of the false expectation of control isn't a defeat. It is the only practical way to harness these memory systems for the exact job they were built to do.